So this chapter 2, we start off, we got some good stuff coming in 2.3, but it starts off kind of basic. You're solving equations. You're solving, you solve for x, and they're just linear equations, okay? I mean, it's still going to be chapter 3 before we get to quadratic equations, x squareds and x cubes and higher level stuff. So a couple more weeks before we get to chapter 3. But, so how hard can we make this? I mean, I think you can solve linear equations. I mean, on a real basic level here. Can you solve for x? Sure, I think you can. I'll just help you real quick. You try to get x by itself. You move this x over here. That's a 2x. You add this 20 over here. Are you guys okay? Mm-hmm. All right, it's basic algebra solving kind of thing. Divide by 2, and here's my answer. X is 27 halves. So this is kind of, I guess I'm sort of in your toolbox, but also your toolbox, I was looking at it, and I took a few notes. Your toolbox, you're solving for x, kind of basic things. And then when you start 2.1, you're solving for x, solving linear equations. Now, they can get a little worse. Here, let's make it a little worse. I mean, they can get a lot worse, actually. Look at this. Yeah, that's a mess. I mean, look at it, though. It's an equation. And when you have an equation with one variable, x, you're supposed to solve for x. And that means gather the x's together, get like terms together, get all the x's together, eventually get x by itself, solving for x. But anytime, listen, anytime we run into these denominators, there's kind of a good strategy. I mean, you can mess around and work with these fractions. You got a 2/5 x, that's one way to think of that. That's a 1/6 x right there, negative 1/6 x maybe. So you could mess around, but it might be cool to just clear your denominators. And you can do that in algebra. You can just multiply the entire equation by anything you want. And it'd be smart to multiply by the least common denominator of all those denominators. What is the least common denominator? 30. It's easy, it's 30, thank you. And I would multiply the entire equation by 30. Now here's what that means. You're multiplying this side by 30. Well, that means you're multiplying this term by 30. You're multiplying this term by 30. You're multiplying this side by 30. Well, that means you're multiplying this term. To me, it's one term here, multiplied by 30. And then the fractions will be gone, and this won't be that hard, but it's sure as a step up from this one. Let's see. The point of multiplying by the 30 is to watch this cancel here. You get 6, right? 6 times 2 is 12x. I'm going to cancel that. That leaves me a 5. I'm going to distribute. That's a negative 5. I'm going to distribute negative 5x plus 5. Are you following me there? Over on the other side, I guess it's a 90, and I think I'll distribute that 90. 9 times 4, 360, and a 90 times 2x is negative 180x. That's cool. That's a cool move. Multiply by that common denominator, and it makes the problem so easy. But you got to know what you're doing a little bit. Multiply by that common denominator, kills your fractions, and now you got a nice problem. Let's see, that's a 7x plus 5. I don't want to, sometimes I do a lot in my head. This time I didn't do much. To avoid a lot of writing, I like to do a few things in my head. But anyway, I sure didn't do much that step. I combined those x's there is all I did. But now I think I'd like to get my x's on one side and my numbers on the other side. So I think I get 187x. Do you agree?
Yes.
And what am I doing? Subtracting 5 equals 355. Well, here's my answer. Now you divide, of course. 355 divided by 187. Yeah, listen, I'm up here making up these problems. And so when I make them up, they could sure have some weird answers. hey, this is college algebra. We shouldn't be scared of weird answers. We're mature enough to handle any, it's just a number. It's just as good a number as 2. It's actually almost 2, but if you're messing around with My Math Lab, they may tell you type in a fraction. They may tell you type in a decimal. They may tell you how to round. I mean, they give you pretty decent directions on what they want. But I would be happy with that. I don't really have, I mean, that solving, I started with an easy one. I did a more advanced one with these nasty fractions. You should be able to handle a little bit of this homework. Again, this is in the toolbox and it's in 2.1. Now, there's another idea in 2.1 though, because in a way, I don't know. We'll have some of this on our quizzes and our tests. But these questions are kind of just solve sort of for the hell of it. Please solve for x. Please solve for x. I really like when you solve for some reason, like some word problem or something that makes you solve instead of just solving for fun. So one thing that happens in 2.1 is we run into this. Now, I don't know if I mentioned this a little early in chapter 1. I might not have. This is a term called the zero of a function. And the zero of a function, I'll tell you what it is. It's the x value that makes the function 0, that makes f of x equal 0. It's the zero of the function. I wonder, can you think of another name for it? It's the zero of the function. It makes the function 0. You could say it makes y 0. You could look at that and say y is 0, and then you're finding the x that makes y 0. You know another name for that?
X-intercept.
Yeah, good. That's the x-intercept. Right. So there's another name for it. I don't know if I used this in chapter 1, but we use it here in chapter 2. It's the x-intercept. It's the zero of the function. As long as it's a real number, it's an x-intercept. I think later this course we might get into some imaginary numbers. An imaginary number could be an answer. It could be a 0, but it wouldn't be an x-intercept. But anyway, we'll get there later. But so in this chapter, a 0 is an x-intercept. It really is. So now watch. So this can be easy. Find the zero of this function. Find the zero of this function. Real easy. If you want to find the zero of a function, it's when the function equals 0. The mistake students tend to make is they'll put 0 in the wrong spot. So if you read what I wrote up there, it makes the function equal 0. That means the y is 0 and you're looking for x. I made a point to call the 0 the x value. I don't know. What do you think? What's the classic wrong thing a student would do here? The classic wrong thing a student would do would they plug a 0 in for x and say they have negative 350, but that's the y-intercept, and that's not the 0 of the function. That's plugging in a 0 for x. That's the y-intercept. Anyway, that's not this. The 0 of the function is what makes y equal to 0. You solve for x. This one's easy. 350. They're all going to be easy if they're linear functions. Divide by 50, x is 7, right? That's the 0 of the function. You know, so I noticed this in the homework, and I don't think I'm going to turn on the homework today. I looked at the homework I got. This is a little preview of the homework. We can look at it next week a little bit. But so I think you'll have some questions, funny questions that'll say, find the 0 of the function. And so then maybe you type in x equals 7. That's the 0. And then then right after that, they'll say, what's the x-intercept? And it's the same thing, and they're trying to get you to think it's the same thing. But you know what they may want? Because it's an x-intercept, which is kind of a point on a graph, I think if they ask for the 0, they might want you to type that in, or just the 7 perhaps. If they ask for the x-intercept, they may want a point, which is when x is 7, y is 0. I don't know. It's the same answer, but they may get picky about how they want it. If it's a 0 of a function, it's an x value. If it's an x-intercept, it's sort of a point, whatever. Just pay attention to what they ask for, I guess. I like the word problems, of course, and the word problems can sort of come in different types. They could say, here's a cost function. This is cost, and x is the number of units that you're building, of course, and they could give me a cost function here. Let's see, 13.6x plus 422. That's a cost function for building X number of whatevers. Okay, this is my cost. So they can ask you this. Watch this. This makes you solve an equation. Remember, the theme here is solving an equation. So they could ask you this. Find the number of units. Find the number of units you need to build that will have a cost of $3,513. So they give you a cost function and they ask you this question. Now, it's not hard. I bet you know what to do. Tell me what to do.
The cost is, well, you would say 3,513 equals 13.6x plus 422.
Yeah, thank you. Listen, you could interpret this as they're giving me a y value and asking me for an x value. That's one way you could interpret this. They're giving me a y and asking me for an x. And so he's right. The cost is this number, so I plug it in here for the y value on the right side of the equation. I plug in 3513. That's the left side of the equation. And then over here, I set it equal to this, and then I solve. So, this is, again, I said I like to make you solve for a reason. So this is a reason. It's sort of a word problem. They give you a y value and ask for the x value, and you have to solve an equation. It's still just a linear equation, and it is easy, but that's a typical problem. Give you a y value, ask for an x value, makes you solve an equation. I'll just help. Maybe you can help me actually. If you subtract 422, if you subtract the 422. 3091. Thank you very much. And then if you divide by 13.6,
227.
227.
941.
0.941.
0.297.
Hang on. 227.27941. Okay, thank you. 0.27. Right. So, again, somebody should give you some good rounding directions. Maybe we're building units here. Sometimes when it comes to these word problems, it helps to use some common sense, I suppose. Maybe you don't build 227.27. Maybe you build 227. Or maybe you go ahead and round up to 228. If the answer is 227 or 228, that's a reasonable answer, but it won't give you that exact figure, will it? But it's close enough. 227 will have a cost a little less than that. The 228 would have a cost a little more than that, I guess. But just pay attention to the directions and what they might want. But it does seem to round to the closest integer seems like a common sense type of answer. That'll get us closest to that cost. Right. You know, so anyway, there's another reason to solve some. So I'm coming up with some reasons to solve equations, like find the zero of a function. That's a good reason to solve an equation. Or given a little word problem, given a y value, can you find an x value? You know, in a little function or word problem. That's a good reason to solve an equation. Both of them are easy solving. Both of them were easy solving. Here's another good reason. Often, again, back to the word problems and sort of this business model. We're curious about when we're in business, we're trying to make a profit, we have costs. If we sell our product, we get revenue, we get money coming in. And I told you, what did I tell you? Profit equals, what did I say? Profit is the money coming in, that's the revenue, minus the cost. Remember that? I said that. I don't think we've used it too much yet, but it's creeping up on us as we go through this course. That's a nice common sense idea. Profit is the revenue minus the cost. But often what we're looking for maybe is when we break even. And when we break even is when, can you make any sense out of what that might mean? What does it mean to break even in this scenario? Do you have a thought, or I can tell you? I guess you're breaking even when your profit is?
As much as your cost or what?
Well, when your profit is 0. That means you broke even. When your profit is 0. When you first start a business, maybe your profit is below 0. Maybe you have a negative profit, which is not good. But maybe you're making more and more profit as it goes. And then if you get a profit of 0, you've broken even. That means, what it means is, see, if your profit is 0, hang on. If your profit equals 0, what does that mean up here? If your profit's 0, what's another way to say this? If your profit is 0, it must mean your revenue and your cost equal each other. Maybe that makes more sense to you. But yeah, that's when you've broken even. The money you've taken in has balanced out with the money that you're paying your employees and everything. And so you've broken even when revenue equals cost. Or you can say when revenue equals cost, or you can say when your profit equals 0. I'm going to say it 2 ways. You guys okay with this? Your break-even point is when your profit is 0, or when your revenue equals your cost. Those are the same thing. Those are the same places. So anyway, that's not a very complicated. I have to. This is economics or whatever this is. It's math class actually, but I'm trying to teach you about these word problems, and that's not a hard concept. Okay, you should kind of think about that, and but you can get that concept, and then that's sort of an application of this. If I ask you for the 0 of the profit function, or if I ask you, here's a profit function. Here's a profit function. When do we break even, or what value of x? Which is x is always the number of things we produce. When do we break even? It's not a time though. When do I break even? And then you're supposed to realize, okay, that break even word means when the profit is 0. Basically, it's the 0 of the profit function. The 0 of the profit function is when we break even. So guess what? You're solving a little easy equation again, okay? All these are solving pretty easy equations, so I like that we need to throwing the words in there makes it just a little tougher, but not that much tougher. You just got to understand the words. So we solve this equation. Move the 320 over, divide by 45. Can you help me? What is this? By the way, when it is word problems, I tend to make it a decimal and round it off. You know, it makes more sense to sort of, you know, not leave it as some weird fraction, but
7.
This is a 7?
7.11 repeating.
Oh, 7.11 repeating. Yeah, okay, we'll probably have to call that 7 in terms of the reality of this situation. Okay, good. I got more to say here, of course, but I need a little